All right, so today's notes are on probability distributions. We are starting a new unit. This is our last unit before your exams in May. So you've made it 2 years. We are almost done. So a few ground rules before we get started regarding the extended break and some procedures. I sent out an email earlier detailing what's going to be required of you with regard to due dates and where you can find things. Not much has changed, honestly. I just need more transparency from you for the homework. So every single day that I have a lecture like this that I'm recording on video, I expect you to complete the homework that goes with that lecture and then to upload it to your homework tab, which I have organized for you with the names of the topics that we're covering in this unit. Try to do that every day so that you upload your homework the following day, and by the end of the week I can do a homework check and make sure that everything is on there like it's supposed to. If I find that you are missing homework, I will document that on ManageBack. I'll send a note home, and I will make sure to say something on your report card comments, which you really don't want anything negative on there because it is the report card that your colleges will see. This is sort of your last hurrah, so do your very, very best. And as always, if something's coming up, I understand the situation is difficult for all of us. Your best bet is to communicate with me on by email or through WeChat. I will be using both, as well as updating your assignment document that Miss Hackett is putting together for you. Okay, without further ado, let's get started here on probability distributions. So I wanted to bring up this question, which is what we left off on before break. And I think this last concept for the previous unit, which was just probability, not probability distributions, was fairly straightforward up until conditional probability. I would encourage you to go back through the notes if you have difficulties with this, because it's really important that you understand conceptually what these concepts are about so that you are able to maximize your earning potential on your paper 1 and paper 2. So if you don't understand this question as I'm going through it, because this is delivered via video, please feel free to pause, rewind, and watch as many times as you need to gain a full understanding. So this says, suppose that the probability of event A is 2/5, and the probability of event B given A is 1/3, and the probability of event B given not A is 1/4. Find the probability of event B. Okay, well, I think the easiest way to do this is to visualize a Venn diagram. So I'm going to go ahead and draw a Venn diagram here, and we're going to look at the probability of B on a Venn diagram. So let's draw one out. I'm using Explain Everything, which is a different app than I normally do, so it doesn't, make circles for me. So if my circles look a little bit derpy, forgive me for that. Okay, so we have event A on the left and event B on the right. If we're looking at the probability of event B, well, it's the sum of the intersection of A and B right here. So that's the probability of A and B. Notice the notation there. And then also in red here, the probability of event B and not A. Okay, so that's what we're taking a look at right now. So we need to be able to find the intersection. We need to be able to find the intersection of A and B and the intersection of B and not A. So how do we do that? Well, we can look at our conditional probability law. This is not given to you in your formula booklet, so you will have to know it, but it will definitely help you. So the probability of event B given A, what is that equal to? Well, that's equal to the probability of event B and A divided by the probability of event A. Remember last time I said that you can rearrange this so that you can just get what the probability of the intersection is equal to. So we're going to go ahead and do that. So this implies that the probability of event B given A, which we have, times the probability of event A is equal to that intersection probability of event B and A. Well, that's one of the things that we want, right? So we're able to, easily solve for this. So go ahead and solve for the intersection and see what you get, and then we'll pick back up from there. All right, so you should see that we can directly substitute from the given values. The probability of event B given A, well, that's given to us as 1/3 from above, and we have the probability of event A, which is 2/5, so that's given to us as well from above. You find that product and you get 2/15. So that's only part of that solution. Now for the next one, like I said, in red here, we have to find the probability of event B and not A. So that's that intersection. Well, how are we going to do that? Again, so let's look above. We're given this. Okay, we have to use our givens. I can't stress that enough. We have to use our givens to solve the problem. These problems are like a roadmap. It's not like you're going in blindly. You need to make sure that if you're stuck, look at what you haven't used yet in the problem and see if that can guide you to the correct solution. So we're going to go ahead and use that conditional probability law again and do some rearranging. But this time, instead of looking at the probability of event B given A, we're looking at the probability of event B given not A. Well, that's going to be the product of event B and not A divided by the probability of not A. So I'm going to write that here, the probability of not A. Okay, so again, we're going to rearrange this, and we get the probability of event B given not A times the probability of not A. Well, that's going to be equal to that intersection that we need, the probability of event B and not A. Okay, that red part of the diagram that we need. Okay, so we're definitely given the first part, that is 1/4. Well, for the next part, how do you find the probability of not A? Pause the video and see if you can find the probability of not A. So go ahead and do that now. Okay, so the probability for not A, well, that's going to be times 1 minus 2/5. Remember, if you take 1 minus the probability of event A, well, you get the probability of not A. All right, so that means that you get 1/4 times 3/5, which is equal to 3/20. So what is the probability of event B then? Well, that's going to be the sum of what we found earlier. That 2/15 plus 3/20. And that's going to be 17/60. So part A, what was hard about it? I think in looking at a problem like this, the key was the Venn diagram. If you understand how to relate probability to a Venn diagram, you can really go far with these types of questions because you're able to see the interplay between the two different events and what you need for the probability of event B. Well, the probability of event B is made up of two regions, right? The intersection as well as that region of B that doesn't include A. So when you add those two together, you get the entire circle that represents B. Okay, well that's only part A, so I'm going to go ahead and erase this board, and then we're going to move on to part B, and then we'll be done, and we'll move on to the new part of this lesson, which is going to be your last unit. All right, so we're on the last part of this question 28 here, so I hope part A made sense. Part B says, find the probability of the intersection of A and not B. So once again, we're going to turn back to our friend, good old Venn diagram. So I'm going to draw a Venn diagram again. Hopefully you sense a theme here. Okay, so I'm going to represent the region that I'm being asked to find on this Venn diagram. So what is that? The probability of A and not B is just going to be that region there, right? It doesn't include the intersection. If I included the intersection, well, that's going to be the entire probability of A. Do I have the entire thing? Yes. Yes, I do, right? And in fact, from the previous question, I went ahead and solved for the intersection of the probability of A and B, right? Or sorry, the intersection of A and B, that probability. So I have everything I need. In just a few steps, I can solve this problem. So that means that the probability of A and not B is equal to that probability of A, that entire region,